An electron of mass m with the initial velocity v equal to v0 I cap, v0 positive, enters an electric field E equal to minus E0 I, E0 constant greater than 0. Okay. Lambda 0 is de Broglie wavelength initially, then the de Broglie wavelength at time t is. So, I will explain this. Do you have any idea about this I cap, G cap? Do you know that?
Yes, sir. The direction.
Direction. So initially there is the electron has mass m and initial velocity v0 I. So here we have an electron. There is an electron. This is electron. Okay. It has the initial velocity. It has the initial velocity v0. I cap means that it is towards positive x direction. Clear?
Positive X.
So electron has mass m. Okay, electron has mass m, and initially its velocity was v0, and we are accelerating this electron. We are increasing the velocity of this electron by applying an electric field. Okay, clear? We are
Okay.
applying an electric field. The electric field to be applied is minus E0 I, indicate that electric field towards left. We are applying a fixed electric field E0. Minus E0 I indicate that electric field
Minus
towards
X.
left. So
Okay.
electric field, electric field is nothing but it is the direction of the positive charge, right? Clear?
Yes, sir.
So if there is any positive charge, it will be forced to move towards left, but the negative charge will be forced to move towards right under this
Right.
electric field. So the electric field, since the electric field is applied towards left, the negatively charged particle will be accelerated towards right. You agree with me? Clear?
Okay, sir.
So the electron will be moving towards right. Initially, when time equal to 0, the velocity was v0. As there is a electric field which is equivalent to a force, since it is equivalent to a force, the velocity will be increased. So our question is, when time equal to t, clear? When time equal to t, what is the de Broglie wavelength? That is a question. Clear?
Yes, sir.
First of all, let us find out the velocity at time t. If we are able to find the velocity at time t, we can easily find out the lambda. Okay, clear?
Mm.
It is given that lambda 0 is the initial, clear, lambda 0 is the initial wavelength. Understood?
Mm.
Initial de Broglie wavelength, because initially it was moving, so it has a wavelength, right? So let us start. So my objective is I want to find the final velocity. Clear? This is the path of
Mm.
the electron. I want the final velocity. So you know that the acceleration, okay, the acceleration, if the electric field is applied, we can find the acceleration. Do you know that?
Yes, sir.
Well, how to find out the acceleration of the electron?
Uh, E equal to V by L, B L, sir.
No, that is not the way. Listen, you know that accelerate the electron will be accelerated, there is no doubt. I will show you all the steps so you will not get in confusion. Force on electron. Okay, let me write all important steps. Force on electron, this electric field is the force per charge. Clear? Force per
Mm.
unit charge, that is E0. The
Yes.
electron has the charge E. Understood? Clear?
Mm.
Electron has the charge E. So the force on electron will be E into E0. Understood? Clear?
Okay, sir.
Okay. E0 is the force. Actually, E0 is actually a force per unit charge. Electron has the charge E, so force on the electron will be E is 0. Then acceleration of the electron. Acceleration equal to force divided by mass. You know this formula?
Yes, sir.
This is the most important formula. Okay, A equal to acceleration of any body is equal to the net force acting on the body divided by mass. So F is E into E0 divided by M. Okay, clear?
Okay, sir.
So accelerated, no doubt in that. So the final velocity, let it be V. Final velocity, I have no idea, V. The fixed acceleration. So the final velocity V equal to, you have studied that V equal to U plus AT, correct? Clear?
Yes, sir.
We have to use that formula, final velocity, V0 plus AT. V0 is V0 itself. Acceleration is E0 divided by M into T, correct?
Hmm.
The speed will be increased. So I got V. Then we have to find out lambda, correct?
Yes, sir.
Lambda, de Broglie wavelength lambda equal to S by P, correct?
Okay, sir.
I am finding the final, I mean when the time equal to T, what is the wavelength? That is what I am finding. Lambda equal to S by P, so S by momentum. Momentum is mass into velocity, correct?
Yes, sir.
So this will be S by M into V. V is the final velocity. It is equal to V0 plus E0 by M into T, correct?
Hmm.
So I got lambda, but there is no such option. We have to express the answer in terms of lambda 0, correct? Clear?
Okay, sir.
There is no form, there is no option like this. All the options contains lambda 0, so I have to reduce to lambda 0. So lambda 0 is the initial wavelength of the electron, correct?
Hmm.
So look at this picture. Lambda 0, can I write lambda 0 as S by M into V0? Is that correct?
Hmm. Yes, sir.
Yes. So okay, I want to include lambda 0 in the final answer. So we know that lambda 0 equal to H by mv0. So if I do the cross multiplication, H is equal to mv0 lambda 0. Is that okay? Clear?
Yes, sir. Okay.
Why I do the cross multiplication? Because I want to include lambda 0 in the final
Lambda
answer.
naught.
Okay.
Uh,
So H is this. So can I replace H by this value? Understood?
yes, sir.
So in the final answer, let me replace H by this value. So I got M into V0 into lambda 0 divided by M into V0 plus E0 divided by M into T. Correct?
Hmm.
So what happens next? Next step, M cancel. Clear?
Yes, sir.
And also V0 is not there in the option, only lambda 0 to be there in the option. So let me divide numerator and denominator by V0 so that V0 can be eliminated from numerator side. Okay?
Hmm.
I want only lambda 0 in the numerator side, that's why. So V0 cancel, numerator will be lambda 0, correct?
Yes, sir.
Denominator also I have to divide by V0. So you see that V0 by V0 becomes 1. Denominator will be 1 plus.
E
Yes.
V naught
Yes.
T by M V naught.
Yes, correct. MV0. Clear?
Option is
Okay.
okay.
So please note the question, okay? In the NEET exam, if you come across this kind of question, you must be able to do that. So answer is option A.